look at two last ones and see how we fare. So again, we want to find, we'll be told what to find, so we want to find all of these things. And we're going to start with the x-intercept, so I'm going to let y equals 0. Negative 0 equals x squared minus 9x plus 8. That is factorable, so 0 equals x minus 8, x minus 1. So I'm going to have x equal 8 and 1. 2, 3, 4, 5, 6, 7, 8. There we go. By my y-intercept, that x equals 0, so y equals 0 squared minus 9 times 0 plus 8. So y equals 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and now I need to find my axis symmetry of my vertex. I can do an average, or I can use that new formula I just found, negative b over 2a. And you can say that's going to be negative 9, so 9 over 2 times 1. So 9 halves. So my vertex is going to have x-coordinate of 9 halves, which would be 4.5. So 1, 2, 3, 4.5. And you don't have to draw your axis of symmetry in. I'm just doing it so we can see it. Okay, so now I need to find the y-coordinate of this, so I can do that by subbing it in. Go down here and do that. Y equals 9 halves squared minus 9 times 9 halves plus 8. So 81 over 4 minus 81 over 2 plus 8. Find a common denominator. 81 over 4. 81 times 2, 162 over 4 plus 32 over 4. So negative 81 plus 32 over 4, which would be, what, 49? I think so, 40, that'd be 72 plus 9, yeah, so 49 over 4, negative 49 over 4. So that would be a little over, 4 goes into 48 12 times, so a little over 12. So I'll go down to 12 and make it a little over 12. And that should be my vertex. Okay, so I can draw my graph in from here. God, I'm really bad at hitting the points. But it should look something like that. And let's see, again, it's pretty obvious that it has a min. So I'm going to get, that would be at the bottom point, which was negative 49 over 4. Domain of every parabola, since they all look the same, they're all going to hit all the x's. So negative infinity to infinity. And my range does have a bottom point. Again, it's at that negative 49 over 4. It hits it, so I'm going to use a bracket. It doesn't have a top point, it keeps going up. So up to infinity. Actually, I'm going to change this a little bit and make that a minus 2x squared for the next one. Alright, so that one's done. Let's do the last one. Let's do y equals negative 2x squared minus 4x minus 3. So I changed it a little bit, sorry about that. We're going to have this now. We're going to try to solve this. So x-intercept, I'm going to let y equals 0. So 0 equals negative 2x squared minus 4x minus 3. We can try to factor it. Let's see, I could do the whole thing where I multiply the minus 2 times minus 3. So things that multiply to positive 6 add to negative 4. I don't know any, so it's not going to be factorable. So I can solve it any other way. So let's solve this one by completing the square. So I'll move my 3 over and get negative 2x squared minus 4x. So, and I want that third space. I'm going to divide everything by the negative 2. So negative 3 over 2 equals x squared plus 2x. And again, I want that third space. So I want to factor this. So my first terms will be x and x. Things that multiply to that blank space add to my middle will be positive 1 and positive 1. So I need to add a positive 1 there in order for it to work. So I'm going to add a positive 1 over here. So it does factor to that. So I do get x plus 1 whole thing squared. Over here I get 1 minus 3 halves. So that would be negative 1 half. So I can even stop here. This can't have x-intercepts. Hopefully you see this. I can't take square root of a negative, so it's going to have imaginary intercepts, or imaginary roots. That's weird. Okay, well, I don't have x-intercept, so let's move on to y-intercept. So y equals negative 2 times 0 squared minus 4 times 0 minus 3. So y-intercept is going to be negative 3. Okay, let's try my vertex or axis of symmetry. Since I didn't have x-intercept, I'm definitely not going to be able to average them. So let's go ahead and use the formula, negative b over 2a. So negative b would be negative negative 4, so 4 over 2 times negative 2. So 4 over negative 4 would be negative 1. So my vertex is going to be at negative 1. So my axis of symmetry is this line. Oh, that should have been x equals up there too. Is this line, x equals negative 1. I am really bad at, dang it, drawing lines. That's here. Let's make that negative 1 now. Ignore how horribly I am at drawing straight lines. Alright, so my vertex at negative 1, that means I need to know my y, so let's sub it in. So I'll get y equals negative 2 times negative 1 squared minus 4 times negative 1 minus 3. So negative 2 times 1 is negative 2 plus 4 minus 3. So negative 2 plus 4 is 2 minus 3 is negative 1. So my vertex is at negative 1, negative 1. So again, my vertex, this has to be either the topmost or bottommost, it's a turnaround point, and it's going to hit my y-intercept. So it has to go through that y-intercept. This is why it has no x-intercepts. It actually opens down. So all the other ones opened up, this one opens down. So no x-intercepts. My domain is still going to be negative infinity to infinity because it's still going to hit every x. Every x is going to exist. It's never actually going to hit the x-axis. My range this time goes all the way down. So this time, the bottommost point is negative infinity. But it does have a stopping point still. It stops going up. So it gets up to 1 and then comes to a hard stop. It always goes lowest to highest, so make sure your domain and range always go lowest to highest. Like most things in life, you say you have 2 to 5 people coming over. You never say you have 5 to 2 people coming over. This time it doesn't have a min, it goes all the way down, it has a max. And it has a max at negative 1 at that stop point. So that's it. Okay.